Okay, guys and gals, if you remember, on the bed of this vise, this groove over here on the side closest to you that holds the jaw was a full half an inch, a little over half an inch actually, like 509, and this groove over here was 390 something. So it's about 100 thou smaller, a little over 100 thou, 111. I measured it all, worked out to 111 thou narrower on this side than this side, so they're kind of out of whack. So I want to get this set up here on the bed, put a tool in the horizontal spindle, and cut this groove to be the same width as this groove over here, so we're centered on the vise. I've got, what I did to start here, take digital calipers and just measure roughly here to get the vise centered on the, as far as getting this thing lined up. Use the calipers to get it close. 1090 and 1093. All right, there we go. I've got two studs mounting this thing down to the table. I've got them hand tight so this thing just doesn't bounce around. And then I'll show you a shot here in a second of, I got an indicator set up here in the back. You might just be able to see the top of it. Mounted on, using a Noga arm, mounted it on the ways back here. And I've got the indicator indicating off of this edge, the edge we're getting ready to cut. Now, honestly, I don't know if it's straight, right? I got it mounted in a position here that I think is good enough to make this cut, because we'll be recutting this surface. But we're going to go ahead and indicate off of it just to check it. I want to show you how we do this. So I'm at the back of the machine. I've got rear controls here. We're going to fire it up. It's going to make some noise. Then I've got access to feed and rapid right here without turning the spindle on. So I'm going to feed. I've got the indicator 0 here. I'll just wrap it on down. Puts me a good ways out. Right, I'm good with that right there. I'll go ahead and give you a shot. I'll go ahead and get you a shot of this so I can cut in and show you the setup before I tear it down. So there's our setup right there. The indicator indicating off of this surface here. To be honest, I haven't referenced this surface off anything else in the vise, so I don't even know if that's cut straight, right? But we've got it lined up. So now we're going to get a tool mounted, and we're going to go to work. Also, I'd like to point out my spindle cover. One of my YouTube viewers noticed the rag that I had stuck in the spindle and said, why don't you print one? So I did. We'll show you a little more of that later. All right, we're going to mount our tool in, and wanted to share a little info with you. Some of you guys have probably noticed that recently Adam started using a TG150 collet system. This is a TG150 collet for 1/2 inch diameter. This is an ER40 collet, which is extremely popular, 1/2 inch diameter. There's a little side-by-side comparison for you. Here's the clamping nut for the TG40. The TG40 collet is considered a 2-angle collet because it clamps on this taper and this taper. And you'll look at the way the cuts are in the TG40 collet, and it's cut from both sides halfway, right? TG40 collets have a lot more range. This one goes from 472 to 511. This is a single angle collet. It only clamps on one surface, this long surface here. You'll notice the angle is a lot shallower on the TG collet and a lot longer. It also has a much less wide of a range. This one's good for a 1/2 inch, and that's it. It's good for a 1/2 inch tool. The reason this is called a double angle collet is because if you look up inside the nut here for the TG for the ER40, you'll see this clamping surface. This actually clamps against this surface right here. And what are some of the advantages of this are you need fewer collets to cover a wider range of gripping diameters. Of course, in a tool holding setup like this, it's really not that big a deal, right? But as far as range goes, you don't need a whole bunch of these. It's not like 5C collets where you're holding work. You know, what do you, I mean, 1/16 maybe? I mean, who buys? Been a long time since I bought a 9/16 end mill, right? But they're also a whole lot cheaper and a whole lot more readily available. And obviously, since they have such wide ranges, you can hold standard and metric sizes in one collet. Now this, the TG150 collet with the long single taper collet, the advantage here is these hold much tighter than the ER40s. TG stands for tremendous grip. I believe they were invented by the Ericsson company. There's several sizes. I believe they go all the way up to like TG250. I've never seen one before. That thing would have to be this big. Down to TG50s. I've got a TG150 and I've got a TG75. Let me show you that. Here, this is a TG75 collet for 3/8 of an inch. So you see it's still a single angle collet. And of course these much smaller tool holders. I've got pretty much full setups in all three of these sizes. The TG150, like I said, is much tighter grip on the tool, has much more gripping surface. Look through here and here, you see how the gripping surface comes. The gripping surface in the TG150 is as long as the entire collet on the ER40, and it's going to get much tighter grip because you've got a shallower angle and a longer angled surface to tighten up on. So that's just kind of some of the different collet systems that I use in the big mill here. Of course, I use ER40s. I've got ER40 holders for this machine. I also have an R8 ER40 holder from my Bridgeport clone. And I also have a Morse Taper 3 ER40 holder I can use in the tailstock of the Rivette. So these are real versatile. You're going to have a hard time finding an R8 holder for a TG150 probably. Anyway, so we're going to use the ER40 here today when I mount this tool up. And let me go ahead and put this stuff away and get ready to go. TAZ4 flute, 1/2 inch carbide end mill. Kind of tight back here, so I've touched off on that inside face. I'm going to come down until I touch off on this end. Alright. I'm going to set an indicator. And come in, we'll take 25 thou for our first cut. How about that? $10, $20, $5. Okay, well, let me speed that spindle up a little bit. We're going to speed up to 775 RPM. We're going to be feeding at 2.6 inches a minute. so there we go. As you saw in that last little cut, I went ahead and skim cut this other side just so that I could make sure I had the same Z from side to side. And I'll even do myself the disservice of putting a measuring tool on it. Yeah, right on there. Basically, this is 1 5/8 from the surface here to the bed right there. So anyway, so what I did is I went ahead and I measured this distance here. Our new distance from rail to rail is going to be less. It's 4.83. Currently, the machine, the way it was set up, was 497, almost 5 inches exactly. And then after we trimmed it down, we're down to about 483. So what I'm going to do is I'm going to take a cut across here, a lot of this, cut across here, and leave myself a notch to put a piece of material in to make a new edge. And I'm going to make it deep, and I'm going to make it bigger than I need it to be, thicker than I need it to be, so that once it's attached and fit and ready to go, I can recut this edge and maybe this edge over here to get as close to this distance as possible to get a nice fit. And then the next thing after that will be, we got a lot of slop between the bottom of the bed and here, the retaining plate. The retaining plate right here is worn badly. So what I'm probably going to do here is I'm probably going to skim cut this, and then after this is done, we'll refit this on the bed, figure out how much slop we have, and then I'll probably take some material off right here to tighten that up. It doesn't have to be real tight. This is not a milling vise. It does not have any part hold down capability. So it's a drill press vise, and it's not a great drill press vise at that, but we're going to resurrect it. So let's get set up to take the cut off this shoulder here and go from there. I got to reload the vise back on the mill, so it'll take me a bit. I'll be right back with you. Alrighty, so how in a shop where I'm mostly by myself do I move around 8-inch curved vise? I tell you right now, I don't do it by myself. But this little contraption here, it's rated for 300 pounds, which I would expect I work out well past capacity sometimes. Does a pretty decent job. It's got 2 little forks and a flat, which you'll see here in a second. It allows me to raise it up and slide things on and off the table. Alrighty. There you go. Alrighty, we're set up here in the mill. We got a big roughing mill here. We've got to take off at least 4 we've got to take off at least 650 thou. This dimension here is really just kind of up to me. So we're going to take a really good bit of that off to give myself plenty of room to secure the replacement. I'm going to come in here and touch off, running about 250 RPM. I think we got a touch there. Yeah, we got a little nick. All right. Action on zero my dial. Come in. So that's about 2.5 inches a minute. We're running 200 thousandths depth of cut, and we're taking about 3/4 of an inch radially, I guess. That's a pretty darn good finish for a rougher. I'm going to dial in another 200. Maybe we'll go 300 this time. This is a 1/4 inch depth of cut radially. Alright, here's our last cut. We're going to take one of the So we have made the major cut on this piece. Cut off approximately total 875 by 612. That was our depth of cut. We're going to have to add to that 612 approximately 370 to come up with our total amount that we need to add back in there, which is 982. So what I'm probably going to do is just make me a 1-inch block that's 875 wide. We'll make a 1-inch tall block. We will probably braze that in, and then we'll mill it down and mill it to width to get our proper width to go back on the vise here, and we'll go from there. I did mention earlier that I've done some 3D printing, and I want to show you the first thing that I did mention, which was the spindle cover. Let me get that. Here you go. This is the spindle cover that I printed. One of my eBay viewers, who I will post his name up here, said, "Hey, you're gonna get this rag in your spindle, and but you know you got that 3D printer. Why don't you print a nice little cover?" So, printed this thing here. It fits nice and tight. You'll notice where I removed some material in here. if you print real thick sections, at least I have found, if you print thick sections in ABS, that is prone to warping and badly. But if you do stuff like this, thin sections with stiffening ribs, it tends to print pretty good. The other thing that I printed, which hopefully you'll find interesting, is in pursuit of repairing my Carney Trekker, as I've mentioned, I needed a dividing wheel with multiples of 11, which I don't have. And a YouTube viewer, I believe Shadow Dog 500, said, "Why don't you just print one?" Well, so I did. This is a dividing wheel to go on my Carney Trekker Model H over there, with 11 divisions in it, which will allow me to cut the spacing I need for the 55 tooth gear for the pacemaker. So I'm going to get this mounted up here soon, and we're gonna make a test cut on something other than my gear, obviously, just to see how well this plastic works, because of the way the wheel works in the dividing head. The way you clamp it is by clamping on the OD of this piece. I don't know how well it's going to work as plastic. You'll also note I only put one ring of holes in there. I didn't want to weaken the piece by perforating it up with a bunch of holes like a metal one would. So, but if this works okay, boy, does this open up a lot of possibilities, right? You need some kind of weird plate that you don't have, poof, print it, right? And there you go. It's I think that by the time you average out all the potential sources of error, that this printed head here is going to work as well as just about one I'd make on a Bridgeport. So, if not as well. So, anyway, come here, Rose. Some people want to see the cat. Come here. Whoop. Here she is. She's getting bigger. She is a little terror in the morning, let me tell you. Anyway, give you a little view. See how big she's getting there. Oh, chip. So anyway, be safe in the shop, and I'll be back with you soon.